Economics was interesting for me, and from there I started reading about finance.
What does a data scientist do?
Predicting something that is useful for the business.
How these data teams collaborate, how these different data roles differ from each other, and what specific problem each role solves.
They build data pipelines. The same data is being utilized by the data scientists.
What type of algorithms you use at each phase?
And deep learning techniques, boosting techniques.
Let's move on to a rapid fire round. Statistics, machine learning, deep learning. Hello everyone. Welcome to Beyond JD, the podcast where we uncover the real stories behind roles, growth, and hiring. Today, we are going to discuss one of the most talked about role in tech, the data scientist. So, in this episode, let's break down what data scientists actually do, what skills they need, and how one can enter this field. And to share the practical insights, we have a very special guest, Sampath Kumar, Senior Director, Data Science at Yubi. He has over 10 plus years of experience in data science field and has recently filed a patent for his collection campaign optimization solution. Welcome, Sampath. Thanks for accepting my invite. So, tell us about yourself. Can you brief about your career journey so far?
Yeah, I'll do. Before that, thanks for inviting me as well. This is my first podcast, so
Nice.
happy to be part of this. My journey, I did my engineering at CEG. Post that, I had a 6 months work experience with Accenture as a software developer, and then I did my masters in finance. I was always interested towards numbers, math. So I wanted to that interest moved me towards doing a finance course. So I enrolled for this masters in finance course in Delhi. Completed 2 years there, and then I joined a firm called DE Shaw, which is a quant hedge fund. There I was helping traders in London by building financial models.
Okay.
It was more into financial model building financial models where basically what should be the right price to invest in a particular security. uh, uh, Building predictive models for that to arrive at the right price, working with the traders closely at London. That is what I was doing. That also exposed me into a field called asset backed securities, mortgage backed securities. With that experience, I wanted to move back to Chennai. I was at Hyderabad and I wanted to move back to Chennai. When I was searching for different roles, I came across this company called Vivriti Capital, who were doing securitization and similar kind of roles out of Chennai. That was a fintech that was 2 years old, which started, and I wanted to join a early company so that I grow my career. At that time, I had around 3 years of experience. I wanted to start somewhere early, so along with the company, I also learn faster and grow faster. With that motive, I joined this company, where they were also looking for a data role in that particular field. So I joined there as a data scientist, and from there I've been part of Vivriti Capital. From there, transitioned into Cred Avenue, and then I take care of the data for one of our acquisition companies called Spocto, who are into debt collections. This is my journey. I started as a financial analyst, so I think 10 years back, it was more about the role data science was getting shaped, I would
Okay.
say. At that time, there was no clear role of data science in every industry or every team. There would be people who analyze the data and uh, do some predictions out of it. That became more and more clearer in the market as well, and for me as well, it became more and more clearer. And I've been I've been continuing with this role of data science for the last 10 years now.
Nice. Okay. So, actually, on hearing your story, right, I can sense that you have crafted your career journey so well. Like, it was you did your engineering in Triple E, right?
Yes,
Haha.
I did in engineering, uh, but I wanted to. So what happened is, during third year or fourth year of engineering, I my roommate was preparing for UPSC exams.
Okay.
So he was reading about economics and all those. So I just started reading some books there. Economics was interesting for me, and from there I started reading about finance, and that was very interesting for me. So then I decided, okay, I want to do my career in finance. Then I got into, I saw about this role. So one of the seniors, I got in touch with them, understood what is the course about, what they teach there, etc. The curriculum was very interesting and it was aligned with what I want to do.
Okay.
That's where I started. I started venturing into finance, and luckily I have been in the same domain of
Nice.
financial services and fintech.
Nice. So you have chosen the domain very early in your career stage, as well as the relatable role, which everything depends on your interest, the numbers, the data, right? So fintech plus data science, it's a beautiful blend, right? The
Yeah.
domain plus the role.
Yeah,
Yeah.
correct. Absolutely right. So, uh, I chose the domain, and then my natural interest was also towards numbers and uh, breaking down numbers, understanding something around it, or uh, using numbers to predict something, tell a story with the numbers. That part I like generally. So that made me. I think that interest itself shaped my career.
Right, right. Yeah, yeah. Very well said. Yeah. Your interest shaped your career, and that's one of the main reason you have grown to a senior director position right now.
Yes,
Yeah.
correct.
Yeah. So now let's talk about the role data scientist. So what does a data scientist do? So what's your roles and responsibilities?
As a data scientist, the if I want to say it in a single line, it is about uh, predicting something that is useful for the business.
Okay.
The predictions could be around multiple things. Uh, let's say we are into a simple example. Let's say you are into trading. The prediction would be what would be the price at which the securities would be trading on. Let's say you are into supply chain business, then the prediction would be around how much inventory I should be maintaining. Even for FMCG, what should be the price at which I should price my products. There is always a need to predict in any of the industry.
Right.
So that is what data scientists are supposed to do. Uh, this is the core. The core has always been the same. Just the way to do it, or the outcome of it, where it is getting integrated uh, with more and more technology. What I'm seeing is, even before the predictions have been happening, even before data science as a role was defined, predictions were happening. uh, they were very simple predictions, like, even if you, let's say, last 4 months, the sales is around 80 to 100. It is fluctuating in that range. Even if you take a average and tell for the next month, it is a prediction. What data scientists do is they take into account other factors that affect this month. There could be a factor. Let's say you have the 4 months which I mentioned, could be Jan, Feb, March, and April, and we are predicting for May. Now May could be a holiday season, so the sales could be higher. Uh, let's say you are predicting for a particular product that is also dependent on weather. Then the numbers vary. So there are n number of features or variables that affect this final number that you are predicting. So data scientists use technology to bake in all these features into something called a model, using the historical data, and then they predict it, or technically they call it score it or infer it at the time, at the time whenever it is required. Previously this was done more offline, where the predictions were made using Excel, or with simple functions or basic statistical models. Now the accuracy of prediction is improving because of more and more sophisticated algorithms that we
Okay.
have, and the way business and the technology teams interact um, has also evolved significantly. Now the predictions are not just for the business teams, it's also for the end consumers directly, where there is a product interface in between. They interact with the product, where the model APIs are invoked, and that does the prediction and give back the predictions. So the way it is consumed, because of the engineering scale that we have achieved, it is the predictions are now done at a much larger scale, and the way of predictions has also evolved with more sophisticated algorithms.
Got it.
But the core role is always about uh, predictions, how accurately you can predict, and then you get the feedback of the actual numbers, and then you refine your predictions month on month.
Got it. So it's all about the future predictions. So that's
Correct.
why they have coined the right term. So scientist is someone who discovers something new, right? So
Correct.
your so data scientist is someone who you discover new insights with the existing data.
I wouldn't say insights with the
Okay.
existing data. So
Okay.
this is where there are multiple roles within data. Uh, if there is a role called data analyst or business analyst, whose predominant role is about generating more and more uh, meaningful insights for the business.
Okay.
That is the role of a data analyst or a business analyst. Data scientist is more about predicting the next step.
Okay. The future.
It's
Okay.
more about predicting for the future, so that certain decisions can be done better using those predictions.
So as you said, there are a lot more other data roles, right? So
Yes.
if you take a data team, there are a big data engineer, data analyst, as you said, data scientist, ML engineer, also data architect. So there are various roles. So let's say assume like a new project is coming in. How these data teams collaborate with? Like, can you talk about how these different data roles differ from each other and what specific problem each role solve?
So what happens is, let's assume there is a product.
Okay.
uh, there is a need for a certain prediction to be done. um, let's assume the product is around stock market, and you are trying to predict the future price for the users of that product. Now that is the business problem that has come to the team. I'm leaving out the stakeholders who explain this problem. For a moment, let's assume that the business objective is very clearly defined, and that is translated into a data problem. Now, what happens is, there are certain data that you require, historical data that you require to build your models that can predict the future. Correct.
Okay.
Now, these data points are being sourced by a team called data engineering team.
Okay.
Data engineers within that, you can call a subdivision called big data engineers, who deal with higher volume of data, more high frequency of data. They could use more sophisticated frameworks like Spark, etc. But the data engineering team is responsible for uh, bringing two broad data sources into a data warehouse or a data lakehouse, etc. So let's say you have internal data.
Okay.
Where, let's say there is a product. The product itself generates a lot of data. Whenever the users come in, users click, however the end user interacts with the product, there is always a data point that is getting generated, and that gets managed and stored by the software engineering team in their transactional databases. But you cannot build your models on top of the transactional data. uh, it is it is never a right thing to hit the transactional databases, uh, because of the sanctity that has to be
Right.
maintained. So what data engineers do is, they they build data pipelines, so that the data can be moved from there to a place called data warehouse or data lake house or
Okay.
simple data lake,
Okay.
they move the data there. So that is a place where the data required for, be it simple data analysis or
Okay.
more complex tasks like predictions, etc. For all the use cases, all the downstream applications, the data is utilized from there. Now data engineers also bring external data from external data sources. So they could be doing some simple web crawling, or they could be hitting some external APIs to source some external data, and they bring it to a place called consolidated place called data lake. In data lake also they maintain multiple layers. Data lake you can consider is like the raw data.
Okay.
Every data whatever is required, that comes and gets stored in data lake. From there, depending on how the end users want to see the data, because let's say there are hundreds of tables, you don't want to do all the complex joins and everything at the runtime, or even at the model creation time, or the feature generation, everything you don't have to do at the time of model creation. Those are standard contracts that are defined, and basis the contracts they create different views or tables on
Okay.
top of this data, and store it in a data warehouse,
It's a structured form of data.
more structured,
Okay.
that can be utilized faster by the downstream application. Now that data is ready. From there, the data analysts or the business analyst, they use the data to understand what is happening in historical data, and they generally there are data visualization tools like Power BI, Tableau. They build certain, or it could be a simple automated reports. They build all these reports and dashboards which are used by the end business users for them to understand what is happening in the data. The same data is being utilized by the data scientists, who model based on the business objective, who creates the model that will predict the future metrics, or I would say future whatever has to be predicted based on the objective function that is being predicted. That core model development and the model iterations are being done by the data scientists. And once the model is created, it has to be deployed somewhere. By deployed I mean it has to be put in use, in simple terms, so that whenever there is a request from the product, the model is getting invoked, and it does the prediction, and call back to the product that this is the predicted number.
Okay.
So
Okay.
whether it happens in a synchronous manner or asynchronous manner, this integration along with the product, so that nobody has to, let's say, whenever I want to know, for this particular month, or let's say in the next 5 days, what is the expected price for a particular security, it should not be like somebody asks, send me a request, I sit manually, run my model in a Jupyter notebook, and then tell them this would be the number. This happens automatically, right? That is the deployment related things that are mainly managed by a team called ML Ops.
Okay.
Now, ML engineers are more like who take care of both. There is a more advanced role now, I would say. In software engineering, you have, right? People start with front end or back end, and then they become full stack.
Right.
This is more like a full stack role, you can say, where the end to end related to model, that is managed by the ML engineer itself. Sometimes even the data pipelines that is required, that also they are capable of building it. So that
So the models which you strategize for predicting the future metrics is built by ML engineers.
built by data scientists. So data
Okay.
scientists are purely into this modeling.
Okay.
And ML ops is the role who deploys this model and puts it into production.
Okay.
Now ML engineers are more like who does both of these things.
Okay.
So they also build the model, they also maintain the model, they also maintain the productionizing of the model.
Got it.
Okay, so all these three things put together is being done by a ML engineer itself.
Got it. Yeah.
Okay, so these are the different roles. Architects are basically there are two kinds of system designs that are required. One is for the data engineering side of things, and another is for this deployment which I mentioned. So if you see, let's say, what frameworks or what tools should be used for the quantum of data that you have, and how it has to be, how the cron jobs has to be set up. Should it run on a, if it has to be real time, then there has to be a live streaming of data. If it has to be on a particular frequency, then different set of tools are required within data engineering itself. How the data flows from a transactional DB till it comes into a data lake and then a data warehouse or a lake house, that end-to-end system design or architecture, and even the ML model related side of architecture, um, these are owned by a team called data architects, who
Got it.
does this system design things.
Okay.
So these are the different roles, different participants within the data team who manage the outcomes end to end.
Got it. Yeah, very well explained. So, okay, let's get deep into data scientists now. So, you told like the main job of data scientist is to predict the future metrics of any business, right? Can you give some examples of such future metrics? Like, what exact business problem does this role is solving?
Yeah, I'll give some examples which can be more relatable by a lot of people.
Okay.
Let's say one could be, let's say you are into a financial services business. One key thing they do is they give out loans.
Okay.
Okay, the banks or the financial services, NBFCs, they give out loans. So uh, who should be the right person to give out a loan? What is the default probability? What could be the expected credit loss that, let's say I am giving out a loan of 100 rupees to a person. What is the chance that I'll get back the money? I need to know that, so that I incorporate that expected credit loss into my pricing. Here pricing is the interest rate.
Okay.
A simple example could be, let's say you are a salaried person with so and so income and a stable career, fast growing career in a fast growing field, etc. uh, you are you might get a better, or you might get a better pricing, better interest rate. Let's say your CIBIL score is also pretty high. You would get it at around, let's say, 7. Home loan you would get it at around 7.5 range. Whereas a self-employed person with let's say a struggling, who does not have a continuous cash flow, uh, fluctuating cash flows, uh, he might get it at a slightly higher rate.
Okay.
So that rate difference is coming because of a model called, what is the expected credit loss from this particular person, what is the default probability. That default probability is a number that is being predicted using this model,
Okay.
depending on different, taking into account different features, people with these characteristics, how, what has been the historical default probability. Now another example could be in FMCG business. One key thing could be, what should be the inventory that I should be maintaining. Let's say on a particular day, what should be the inventory that I should be maintaining. Or let's say you are into um, very let's say flight operations.
Okay.
There one critical business problem they face is, they need to know beforehand itself when a particular flight has to undergo a service, depending on certain. So there are a lot of machines inside it and lot of sensors that send certain signals. Based on those signals, there are models that predict when a particular which machine, when it should be sent for servicing. Or in a stock market, let's say the markets are closing, uh, like moving average, different metrics, different features. Based on that, you are able to predict the next day opening price. So these are the different examples where data science people take the business problems and they build models to predict the future outcomes.
Got it. So, as you said, this data science project goes to multiple phases, right? So, right from gathering the requirements to telling the insights or predictions to your stakeholders through storytelling. So, what are the different phases data scientists go through, and what type of algorithms you use at each phase? Can you elaborate on that?
Yeah, I'll tell the phases of end-to-end project,
Okay.
and I'll also touch upon different, let's say, people with different experience within the data science. Uh, let what would be the core focus for them within this end-to-end process?
Okay,
Because
like junior level, mid senior,
हाँ,
or
correct.
okay, okay.
Because if you had asked me the same question, right,
Mm-hmm.
let's say 7 8 years back,
Mm-hmm.
I would have definitely said fine tuning the model is the most important piece in this
Yeah,
end to end thing.
mm-hmm.
Right now, I know more than that, there are certain other things that is more
Mm-hmm.
important. So, the first thing that demands or that controls the 60% of the success of a data science project is gathering the right business requirement and converting that into a data requirement.
Okay.
Okay, so see, data science is also not a magic.
Mm-hmm.
It's not like you'll be able to always, let's say, this stock market prediction, right?
Mm-hmm.
There are a lot of factors that cannot be considered into the model. Uh, Similarly, there could be different business objectives. Let's say tomorrow you ask me what could be the weather, and there is some factor that has not been factored into the model, and it has happened that would affect my prediction. That is why it is never 100%. Nobody, no model can predict 100% accurately. That is why there is always a error metric, and you keep publishing and looking at the error metric to figure out how to fine tune the model. So the 60% which controls the success of a data science project is understanding this business requirement and converting that into a data requirement.
Okay.
Okay. Now, once that is converted into a data requirement with the proper objective function of what is that I am going to predict, what are the features that I have, do I even have the so asking the right questions to the business teams to get the data that you want. Uh, let's say, for example, you are trying to predict the default probability, or let's take an example of what I am currently doing, uh, trying to define a right strategy for a particular customer to get back the money which they have borrowed. Now when the now there are certain parameters that affects this prediction of mine. Let's say, for example, what is the how has been the current repayment history, uh, how has his CIBIL score changed, how he is historically interacting on a digital campaign. If a call center team calls them, does he pick the call or not? Depending on that, I will curate the right set of treatments to collect the money back from this particular customer. Now, let's say I don't have these data points, then I'll not be able to do justice on my prediction. That is where explaining the business teams that these are critical data points that has to be instrumented and be made available for the data scientist in a data lake. That is crucial for the model development.
Okay.
So having the iterations with the business team, both in terms of ensuring that they understand the clear business objective and how that is getting translated to a data objective, they has to be on board with that. And second, telling them what are all the basically interacting with them to understand what are all the data points that are required to make this prediction, and all those features have to be made available for the data scientist. This is one critical part. Next is and that is why I said 60% of your the project success depends on this only. If you get this right, then most probably you'll build the model right, because after this all are very well tested and trained approaches. Then the data engineering team has to bring the data into the data lake. uh, there has to be a contract between the data engineers and the data scientists to ensure the right set of table schema, everything is created. And then the data scientist, depending on the data model objective, the right target variable has to be defined. Then model iterations in terms of feature engineering, all these things data scientists take care of. The data engineering part, I would say 10 to 15%, and then the data scientist iterations are 15 to 20%, and then the remaining is the ML ops team who ensures the model are getting inferred for the business users. Another critical role that comes here is the usage of the predictions. Now, let's say the first month the business users start using the predictions. They might see it could be way off against the actual numbers. Let's say I am predicting for some problem, I am predicting 120, and the actual numbers are around 80 in 1 month. So, my predictions have a very high inaccuracy rate. So then you need to sit with the business users, understand what are all the features that are getting used into it, have you defined the target variable right, and then iterating on the model. In initial 2-3 months, it's about stabilizing the model, and that model stability, more than the model iterations within the data scientist, it more come from interacting with the business users to ensure the right set of features are there in the model and used in the right way, and then the target variable is defined right, and then you create the model. What I would say is it is not 100% technical role. There is a good element of, at least for the senior roles, there is a good element of interacting with the stakeholders, the business stakeholders, or the operational team stakeholders, to ensure the right model is being delivered and they are also using it in the right way.
Got it. So,
Let's say
who are all the different stakeholders you interact with?
different stakeholder, that predominantly depends on the problem statements. Let's say you are working on some operational efficiency related problem, it could be more with the operations team, or you are working on something that is required on the product. Let's say there is a product feature that shows what is the month on month revenue, and for that business the product team wants to show also what is the next month revenue that could be achieved. Now that is a problem statement that you would be working with the product team. uh, in most structured companies, what happens is all the requirements comes through the product team itself. The product team interacts with the business team to ensure the right business requirements are documented. Still, there will be some discussion directly with the business teams. By here business team, I mean, let's say the sales team who are selling the end product, right? Working with them to understand all the features are coming into the database for me to create the model more accurately. Working with them to ensure the right model is being integrated into the product. So product team is one. Depending on the problem statement, the teams could vary. Let's say there could be problem statements from HR team also, who's more likely to uh, leave attrition related predictions, or it could be let's say I want to hire what would be the number of people I would need in this team, or marketing also. Let's say I'm doing different kind of campaigns. Which campaigns are more effective for which set of customers? Marketing, in that case, marketing team is your stakeholder. So depending on the problem statement, the stakeholder varies. Product team would cut across on most of these use cases. On the project flow, now what happens is, let's say if you are into a junior role, for junior data scientists, they wouldn't be interacting much with the stakeholders. For them, mostly the problem statement comes clear. How a target variable has to be defined, what are the features. Their core focus would be into feature engineering, what all more intelligent features I can create out of it, and doing the end-to-end process of a data science model development. In data science model development also, there is an end-to-end process, like you make a training set separate, validation set, test set. In that also, if it's a, let's say, if it's a more cyclical data, then doing a out of time testing is required, then out of sample testing is required. Seeing the model has to be both be accurate and stable also. Let's say 1 month your prediction is very good and other month it is very off, then also it is bad.
Got it.
It has to be both consistent and it has to be accurate also. So for ensuring the stability only, all the out of time, out of sample, these validation testing, all these things come into picture. For making it more and more accurate, you have wide range of algorithms, right? Simple statistical algorithms are ANN, now deep learning techniques, boosting techniques. There are a lot of algorithms that are there. So trying out lot of different algorithms, fine tuning the hyperparameters, creating more and more feature engineered features to ensure that is adding value to your model, ensuring model stability by trying it out on validation sets, etc. That is the core focus for a junior role data scientist. With becoming more and more senior, still you mentor the junior data scientists in these fine tuning, etc. And also you slowly get involved into how to translate a business problem into a data science problem. That transition is also very critical because that will help you to understand how you should define your target variable, right? Because if you set your target variable right, 90% of your data science core problem is solved. And setting that is not, when you take a course, right, what happens is when you take a course offline, in a YouTube or even a in-person classroom, most of the time you will have the data set ready with the features and the target variable defined. But when you get into work, you will understand that defining that is very, very difficult task. So as you grow more and more senior, you get into those kind of thinking. I would say more than interacting with the stakeholders, it's more about thinking. This is my business statement. How should I convert?
So it's about more about setting the strategy, right?
Setting the strategy for the data science problem, right? And then as you grow more and more senior, interacting with the stakeholders, both in terms of model creation and consumption. You need to get the business objective right, and when you are making the predictions, right? See, one thing that happens in the industry, which is slowly reducing also. Many a times the business users will put some use case, models will be built, but they'll not be consuming it. Or they will see the first month prediction is very off and they will lose confidence and not consume it after that. Then for the company, whatever the efforts are put in, that would go for waste. This is where the more senior role comes into picture, where you work with the business stakeholders, understand or explain them why it is off, what could be done to make it better, and then how you take them on board and iterate on the models along with them, then they also get the confidence and they start using the model.
Got it. Yeah.
That is one critical. See, I don't know if it's a technical. It's you need to know technical, but that's not a pure technical role. But a senior has to do this. At the top, what is expected is setting the AI strategy, data science strategy right for the organization at the most senior level. There what happens is you need to, sometimes the business team might not even know this is a problem. They see, when you are into business, right, there is always a constant pressure attached to you in terms of delivering the revenue numbers or delivering on the cost numbers. So they might not even think, or they might not even know this can be solved in a different way. So understanding the business, uh, pitching ideas to the senior management, to the board, and taking them on board and taking that as a problem statement, having a vision around the data science strategy or the AI strategy for the next few years. That is the role of the person who is at the top.
Got it. So now let's move on to a rapid fire kind of round. So I'm going to
Yeah.
list a few skills that are commonly related to this data science role.
Yeah.
So in 1 or 2 sentences, you're going to explain what that skill or the term means and where does it fit into data scientist role.
Yeah.
Yes. SQL.
That is to query from the database. When you have to build the model, right, you need to first take the data and then build the model. So that is for querying the data, taking the data out, and then you work on the
Right.
data.
Python.
That is the language or the script where you, both for your model iterations and for putting into production, Python is predominantly okay. Before we use, when I joined Vivriti Capital 7-8 years back, we started with R,
Okay.
and then every team transitioned into Python. Now Python is the go-to
Okay.
language.
Statistics.
That is core for understanding the models. Let's say simple, there are base models, base statistical models like logistic regression, linear regression, which are more statistical in nature. To understand how the using the features, how a particular prediction is made, to understand that this is required. It
Okay.
is just within the data science, but data scientists, at least the junior data scientists, have to know this, so that when they predict, when the predictions are going off within the model, if something is wrong, right, to make corrections on the model, this understanding is key.
Machine learning.
Machine learning is a broader term where machine learns from the historical data to make the predictions. Data science, machine learning are more interchangeably used. Machine learning is slightly broader, that is also used for unstructured related predictions,
Okay.
etc.
Deep learning.
Deep learning is also an algorithm, I would say.
Okay.
So if you see the list of algorithms a data scientist would have, it could start from the simple ones, more statistical in nature, less complex in nature, and it can go very complex, like deep learning, where you have multiple hidden layers. Uh, those are also statistical. Statistics are used there, but there are multiple algorithms built more complex, with more complex layers of algorithm to make the predictions more accurate. But it becomes more and more complex. There is always a trade-off. The statistical algorithms are very simplest, decent job in predictions, and it's easier to explain. As you go more up and up, you have more complex algorithms which are difficult to explain to the stakeholders, but that does a better job in predictions. But as a data scientist, you are always focused on the outcome predictions. That is the very reason you define a error metric. Because sometimes with the business users, what you need to tell is, see, let's track the error metric. You forget how the predictions are made. let's track the error metric. If it is better, then both of our problems are solved. Uh, so you define clear error metric, and then you have the freedom to use complex algorithms.
Got it. So it's more of elimination technique. Whichever is not needed, error metrics if is rightly said, then
Correct.
most of the problem
And
is solved.
this entire this is also more and more automated. I would say 80-90% is automated. That
Automated,
is where
okay.
you have auto ML now.
Okay.
So let's say H2 auto ML, or multiple companies have auto ML models, which does all the work of a process, operational works that a data scientist do, right? In terms of hyper tuning parameters or feature engineering within the variables available. All those things are done by and trying out multiple algorithms, or combination of algorithms, what we call as ensemble techniques, right? Combination of algorithms to make the right set of predictions. Now, when you make combination of algorithms, right, it's not easier to explain. That is where it also becomes important how much explainability is required. If it's a pure data science problem where only the error metric matters and the model stability matters, then you have the freedom to deploy more and more complex and ensemble techniques.
Time series modeling.
Time series modeling is more about, you have a time series of data at a particular frequency, monthly data, weekly data, daily data, and making the next frequency prediction. It could be for next day, next week, next month, what could be the prediction. There also you can use, there are certain time series models, simple moving average can be used, ARIMA techniques are there. And there are even the machine learning techniques can be used, which has the advantage of bringing in the features into this time series model. So what happens is, in a time series model, right, you just use the time series to make the next prediction. Let's say you can think of it like the technical analysts in a stock market. They just use the stock market price volume data to make the next prediction.
Okay.
So there are certain time series model which doesn't take into account the different features, let's say certain attributes about the stock and all, it will not be taking. Just based on the price movements and volume movements, you'll predict the next price. That is most time series model. You can also bring in the complexity of features and make it more a machine learning model or a combination.
Got it. Generative AI.
Let's say you want to generate a text, you use LLMs there. Now there are a lot of open source LLMs out there. Even what it could be as simple as, let's say you chat with ChatGPT and generate a content. Let's say one Gen AI use case that we do for our debt collection campaigns, right? What should be the content that should be sent to the customer, that we generate using generative AI.
Okay.
So for these kind of text generation or image generation or even video generation, generative models are used.
Okay. Reinforcement learnings.
Let's say you have a good amount of historical data, you can just rely on the machine learning techniques. Now think of a case that where all the possible combinations are not even explored. So what happens is, you do some bit of experimentation, and then you also generate the historical data. With that, you fine tune your models. Think of a case like 80% I use the historical data and make prediction, and 20% I do some random experiments. Now let's say in our collections campaign itself we use this. If you see the possible let's say I am the end customer, there is a campaign being run on me. Now I have there is a WhatsApp sent to me, calling done to me, email sent to me, and I am a customer who has opened my email and I have checked my WhatsApp. So there are certain touch points I've reacted on. Now, given the state I am in, what is the channel that next best channel that I can use, next best content that I can use, next best time slot that I can use. If you see the combinations of this, right? Let's say you have 6 channels available to you. You have 20 different contents, and you have in a day, if you take 1 hour time slot buckets, you have, let's say, 9 hours campaign. If you multiply all these things, the combinations are exponentially it will grow. And if you take this at different steps, let's say on the first day, second day, third day, like that, the number of combinations are exponential. Now it is not possible that uh, at any given point in time, all these historical, so what is historical data? If all these possible combinations are tried and I know what is the end result of it, that is my historical data. But that is not possible in a case where exponentially high combinations of different outcomes are possible. That is where reinforcement learning adds value.
Okay.
It experiments different actions along the way, and basis that it generates the historical data that is more required for the model, and then fine tunes the model accordingly.
Got nice. So we have come to the end of rapid fire questions. So we have got a fair idea of what this data scientist role is about. So let's say someone who doesn't have a experience, let's say a fresher or career changer, wants to enter into this data scientist role. So how they can build a portfolio, or what kind of projects they can do? So can you explain a bit about
see,
it?
I would start with your question itself, and your question is very valid because now what I see, in fact, when I started my career 10 years back, right? At that time, it was more about what course I should join and learn, etc. Now it's about nobody genuinely cares whether you learned through a free course or you learn through a paid course. It's all about the projects that you have done.
Okay.
And the data sets are also available. If you go to Kaggle and you see, you'll have a lot of problem statements along with the data also. Now with that data, you create a portfolio by building multiple models. Um, like for software engineering, there are HackerRank and different platforms where they go and try out different data structure related problems and different hard problems, right? Similarly, there is Kaggle, predominantly Kaggle, where that is for the data scientists, where you will have the problem statement clearly defined and the data also available for that. You need to pick multiple problems from there across. My suggestion would be take it across domains,
Okay.
and then you do that part of data science process which is into hyper tuning, feature engineering, publishing the error metrics. Uh, how do you validate the model stability? This whichever is in your control, right? So you cannot get into discussing with the stakeholder of whether the problem statement is correct or not. Assuming the right problem statement, assuming the target variable is defined right, the data science process of it you do correctly, because whenever somebody is joining, either it could be a fresher or somebody transitioning into this field, for them what is predominantly evaluated for this set of group is, are you able to do the data science iterations, and are you understanding why you are doing these iterations when you say hyper parameter tuning? Because nowadays with chat gpt you get every code ready made available. I wouldn't say don't use chat gpt. Even if, let's say, you get a simple code, right, try to understand what is there in the code, uh, and then you are able to explain what you did and how that is affecting your predictions or the model stability.
Okay.
uh, this is what you need to focus on. Take up 4 5 projects, do that, understand thoroughly what is the data, what after you did the modeling, what are the features that are important, what is the relative importance, how the features are affecting your model, what is your model stability metrics, what is your error metric, how do you what you did for validating the model stability, what are the metrics around that, how do you ensure, what all you did to improve the accuracy. What is the accuracy related metrics? You do this part, you build the story around it correctly, and then you start attending interviews.
Okay.
That
Got
is
it.
this is what is expected for a person entering into the field, be it a fresher or a more experienced person.
So there are lots of materials available in YouTube itself, right?
Yes, yes.
Okay,
So
got
see, I wouldn't suggest. My personal opinion would be there's no need to take up a paid course.
Okay.
You just need to know what all things you need to know. Everything is available in the YouTube. Everything is available in the Google. You just need to Google it, and then put your hands on into it. You start doing it. You will get stuck somewhere. Another way is many people reach out to me also in LinkedIn, like saying they are stuck here, what all they could do, what are my inputs based on my experience. So you reach out to people if you are not able to find the answers in Google. That way, but the core thing is you need to put time into doing it.
Got it.
If you put time into doing it, and also you need to think through, like, uh, don't do it as a process. Understand if you're doing something, how that is affecting your model. That understanding you need to have.
Got
If
it.
you focus on that, then you'll become interview ready, and then it's about getting referrals or whatever is to get the first interview.
Right. Okay. So can you talk a bit about the career opportunities available in India or global markets for this role? Because does this rise of AI have impact on this role?
Yeah,
Okay.
definitely. See, AI is also an extension of this,
Okay.
where you make more predictions on unstructured data, computer vision related problems, or NLP related problems, or even now the generative AI related problems. Uh, those are for specific use cases. Uh, for structured data, I would say still data science. Data science is required, where AI helps us for coding or for defining the error metrics. All these things, the hyperparameter tuning, all these things, AI helps within the structured problem, and the extension of it using unstructured data to solve unstructured problems, there AI is being used. In terms of opportunities, there are, see, in most of the industry there will always be predictions to be made, like I said. So there is a wide amount of opportunities across industries.
Okay.
In financial industry itself, I would say, where, and with more technology becoming, everything getting digital, right? Whatever people used to do manual, in terms of intelligence, uh, all these intelligence touch points are being converted into models, and being that is being done by the data scientists. uh, Across global as well, if you say, uh, there are wide amount of opportunities. But now one thing the market is expecting now, which was not there 6 7 years back, is, uh, 6 7 years back it was more about how strong hold you have on the models,
Okay.
understanding of algorithms. Now it's about uh, how you can utilize the LLMs, what kind of unstructured problems you have worked on. Uh, are you able to do end to end full stack? Let's say, are you able to also deploy a model and maintain a particular model? So it has become wider, I would say. So you need to have that wide set of skills. If you have the wide set of skills, there are plenty of opportunity. I don't see there would be a scarcity of opportunities in this field.
Okay.
Just that the role is becoming more and more wider now.
So let's quickly talk about a few questions on career growth.
Okay.
So nowadays technology keeps on changing, right? So how should one stay relevant to the industry so that they don't face this career plateau?
Yeah.
Like they don't feel like when our career growth comes to slows down.
So, see, that is something that that's a constant question everybody will keep lingering on. Even I continuously think about it. Am I becoming irrelevant? How do I keep myself updated? Especially in data science, what is happening is, like I said, the role is becoming more wider, and with AI coming in and the access of LLMs that we have, it's becoming lot of unstructured problems which were not solved before are getting solved now. So you need to keep yourself updated with the latest AI related things also, in terms of what are the different LLMs, how that can be used into the problem statement, NLP, CV, these kind of things also. And you also need to understand the system design of a model deployment.
Okay.
So because now most of the companies, they are also going product first. There like 10-15 years back, a lot of things were being done as services. Now there is a product to uh, do the same. So in a product, how do you ensure the end-to-end the models are integrated into the product, and what is the frequency at which the model gets retrained automatically? There should not be somebody who is sitting and retraining the model. How that model
Okay.
pipeline is
Okay.
getting automated, and how the inferences are coming on the platform, and how the error metrics are separately getting published in a dashboard, so that data scientists see if something is going off. And also, if let's say the features are also changing, there are certain drift models that you make to understand my input data itself has changed drastically now from the time I built the model. So all these things have to be taken care of, and all these um, individual components, right, that is getting evolved at a much faster pace with the help of AI now. So you need to keep on knowing these things, and see, knowing is not sufficient. In your work, you also try implementing certain things to know whether that is really useful, what is helping in your field, what is not helping. You need to keep knowing that.
Okay. Learning and implementing in the work, day to
Correct.
day work. Right. So, one final question. So, if you had to pick that one skill which someone should be very strong in that skill to excel in this role as data scientist. So, let's say for a product manager, right? Being organized is very important. Like we are the person who are tracking the delivery. So, we need to be organized so that we will be knowing at any given point of time which change request is in which status, so which is going to
Understood.
deliver this
Understood.
month or next month. So likewise, what is that one key skill one should be very strong at?
The skill that I would say uh, that more comes from the experience, and that is super critical, is if understanding the model, and if it is going off, accepting that there are some issues in the model, working with the business stakeholders to correct the model. This because uh, after growing to a certain level, when I see a lot of data scientists, right, if you are just on the model, sometimes what happens, just because I built the model and I'm predicting it, right, if you keep on saying that no, this is the max accuracy that is possible, there is some issue, the business is not using it. If you get into that cycle, you'll never be able to grow. You need to be little more curious and open uh, to take feedback from the business users, even on the model. uh, if there are some valid features that are missing, how to incorporate that and keep fine tuning your model.
So basically, curiosity.
Yeah, I would say
Curiosity.
curiosity.
Thank you so much for sharing your insights so far. It was more of tech, right? So it was you simplified it and you gave a detailed explanation on what a data scientist role will look like. Yeah, thank you for coming to the podcast
Thank you.
and spending your time. Yeah.
Thanks a lot.
Subscribe to our Beyond JD YouTube channel so that you don't miss when your favorite role is covered. Thank you.